Hello, welcome back to the channel. The basics of diag, and we're actually doing a little bit of diag today. It's an easy one, to be fair, but simple faults like this are a good way to give you a foundation, really, when it comes to electrical issues. If you can troubleshoot a simple horn circuit like what we're doing here, then it's really no different to what you might think is more complex. There's a switch involved, a relay, obviously a load, consumer. So yeah, we'll take a look now. Does it matter what car it is? I don't know. It's a 2013 Ford Focus. I've got a wiring diagram, so I'll put a wiring diagram up, and as we can see, there's going to be two circuits that we need to test. There is the consumer side, the load side of the circuit, which is yeah, I think there's a fuse, goes through the relay, horn, and then ground. And then we've got the switch side, which is the button in the cab. That goes through the rotary coupling behind the steering wheel. I think there's a fuse for that as well. And then that goes to the relay. The load on that is the coil of the relay. So I'm going to test at the relay first. It's where both circuits meet, and it's where we can get a good idea of, yeah, the health of the circuit. So if you know a bit about voltage drop, you'll know that the load in the circuit should drop all the voltage when the circuit is in operation. So if we've got a 12 volt supply, when that horn is pressed, we should see a 12 volt drop across the coil of the relay. On the contact side, we should see 0 volts. We shouldn't have any volt drop across the little switch inside the relay. That's the horn side of the circuit, and the horn is the load in that circuit. So that should be dropping all our voltage. Again, 12 volts, because it's a 12 volt system. So I'll show you what we've got set up right now. I've just got using the multimeter built into this snap-on Modus Ultra. You don't need anything like that. Standard multimeter's fine. A little handheld oscilloscope, test light that's got a meter built in. Obviously I like to read the voltage. If you're just using a test light without reading voltage, you can get skewed readings. The bulb may light, but you may only be having a 10 volts across it. You may be dropping 2 volts somewhere else, but it's still enough to light up the test light. So any test light I have has a voltage display in it, as well as the bulb. I've got a cheap one, which was off Amazon, I think, and I've got one from Lyle, which I think came from America. That was off Amazon as well. That's pretty decent. Puts quite a big load on, though. If you do it straight across the battery, it'll drop about 0.5 volt across that battery. So there's quite a bit of load in that. I wouldn't use it for computer circuits, but for bulbs, motors, you know, anything, fuses, because I think it's, well, it says 800 milliamps per 12 volts, so it seems more than that to me though. Anyway, we're getting sidetracked now. Let me show you what we've got going on. So this is what we've got. I've got a relay tester that I can sort of pin out of. I've got it set up there. That's the contact side. A lot of people would go straight for the fuses. I think it was this fuse and this fuse, but both of these supply this relay anyway. So by going straight to the fuse, and if we see 2 supplies, we know the fuses have got to be good. So it kind of whittles down the process, really. Less testing to do. So we'll go in
and show you what the multimeter is telling us.
Right, so this is the contact side, the switch side of the relay, and obviously without the horn pressed we read 12 volts because there's a permanent supply there. We can see that from the wiring diagram. The fuse feeds this straight into the relay, and then as soon as we press the horn, our voltage drops to pretty much 0 because it's just providing a path there to the horn, or it should be. If I release, so yeah, this is contact side. I'm happy with that. So contact side of the relay is fine. I'm going to move my leads now to the other side. Right then, so now we are on the coil side, and we can see it's the opposite way around to the contact side with the horn not in operation. We're at 0 volts. As soon as I press this, 12.09, which is pretty much the same as battery voltage. So I'm happy with that. And look at that. Obviously, a coil of a relay is an electromagnet, and when I let go of the switch here, we get an inductive spike of voltage there. Don't know what it goes to. Don't know. More than 18 volts. And obviously that is sort of similar to what you see on an injector waveform. You get that inductive kick when the magnetic field collapses. So yeah, that's, you know, something interesting that you would not see when using a multimeter. Nice, but obviously we can see we've got 12 volt drop across. Oh my god. Come on, back down. Back down. A 12 volt drop across our coil. We had 0 volt drop across the contacts, the switch in the relay. So the circuit from the horn to the relay is fine. The relay itself is fine. So now we just need to get access to the horn, which I would say, yeah, 80% of the time, maybe a little bit higher, the horn is the issue because they're usually sat sort of more exposed to the elements, water, salt, dust, dirt, all that kind of stuff. But it's just nice to see this sort of electric side of things, the circuit side of things. You know, for the 20% time that the horn isn't the issue, you're going to need to know what you should be seeing. And then from here, if we had like a 6 volt drop across the coil of the relay, we could then obviously work using that relay sort of breakout tester. I can pin from that relay and sort of work back through the circuit and see where the volt drop is. Could be the switch in the steering wheel, but that'll be for another day when I get one that the horn is fine. So I need to find the horn. Awkward. I'll be back soon. Right, a quick Google search has revealed the horn is driver's side front bumper area, so I'm gonna have to move it off the street so I can jack it up and have a look, get my probes in. But that got me thinking, have you ever been doing a diagnostic job, bit of electrical troubleshooting, and you're sort of halfway through, 3/4 of the way through, and your boss or your manager, whoever, has come and asked you, you know, what's wrong with it, yet you haven't finished the diagnostic procedure? Just got me thinking, I don't know what's wrong with it, but I could tell you what's right with it is the answer you should be giving them. For example, with this, we know the switch in the steering wheel's fine. The wiring from this switch to the relay is fine. We know the relay is fine. And now we're working from relay to the horn itself. So yeah, just a little nugget of information instead of sort of getting wound up or, you know, stressed out by the higher ups asking, you know, about when's this going to be ready, what's wrong with it. You know, you can turn around and tell them, well, I know this isn't wrong, this, I need to do this test, and whatever other test before I can give you a conclusive answer. There we are. Let's move this car and get to the horn.
Right, got a bit of the under tray down. This sort of panel on the bottom of the bumper, and up here, horn. So I'm going to back probe that, see what's happening. So another downfall again. The leads too short. Try turning the brightness up so you can see this. If I press the horn now, oh, it works. So what did I do? Well, unplugged it, plugged it back in, then put my back probes in, and now we're working. No parts required. Nice.
There we go then. Horn is now working on this. And yeah, no parts required. What have we learnt? A little bit about relay circuits, a little bit about voltage drop. There was a little bit on inductive kick voltage. Yeah, nice. And because it's my next door neighbour's car, it's probably not going to cost him a penny. There we go then. Thanks for watching. See you next time.